For the last example, let's pick one where you couldn't actually do this using an equivalent circuit. If your circuit has two sources of potential or more, then you're stuck with using Kirchhoff's laws because there's no way to simplify it to an equivalent circuit. So let's start with our process. We'll identify the currents. Let's say that one current comes out of the 28-volt battery. Let's call that current I1. If it came out of the battery, it must have also gone into the battery, which means it went through resistor R. Okay, that current I1, it hits a junction. Let's draw that with a big dot. So the other two currents, let's call them I2 and I3. Let's say that current I2 is the 4 amp current drawn in our picture. So coming from right to left so that it comes out of the positive terminal of the battery, we'll call that one I2. Right off the bat, let's write down that we know I2 is 4 amps. And then at our junction, we have the lower end. We see on the bottom branch, we have a 6 amp current going to the right. I'm going to label that current I3. And we'll write in that I3 equals 6 amps. Okay, so our next step is normally to identify the loops. I think I'm going to jump ahead and I'm going to do our current law first. So our current law states that the net current into a junction, which in this case is I1 plus I2, equals the current coming out of the junction, which is I3. We're asked for the current through resistor R, and that's what we labeled I1. So I1 is equal to I3 minus I2. I3 was 6 amps. I2 is 4 amps. So current I1 is 2 amps. Okay, we've got that one done. So the current going through resistor R is equal to 2 amps. We're also trying to find the value of resistance R and the unknown potential epsilon. So for that part, let's move on to doing our loop rule. And to do that, we'll have to identify our loops. Let's start applying our loop rule now to find our resistance and our potential. First, we'll decide on a loop. I'm going to pick the lower half of this circuit, and I'll draw my loop going clockwise around it. So there's my loop 1. I'll write my loop 1 rule. So my first resistance I come through is my 3 ohm resistor. My potential is going to be a drop because my loop goes to the right, my current goes to the right, so we get a potential drop across the resistor. That potential drop is going to be the current, which is 6 amps, times the resistance, which is 3 ohms. Then next we come to the 6 ohm resistor. The loop takes us to the left, the current takes us to the left, so that's a potential drop of the current, 4 amps, times the resistance, 6 ohms. Next we come to our battery. It has an unknown potential of epsilon. Our loop is to the left, our current is also to the left. That means we have a potential increase. Those potentials have to sum to 0. So our net potential then is 4 times 6, 24 volts. Take away 18 volts to give us, oh, hang on. I dropped my minus when I did my 6 times 3. So if I look at my 3 ohm resistor, the loop goes to the right, the current goes to the right. That's a potential drop. I think I said it, but I didn't put in the words. So then my epsilon is plus 24 plus 18, there we go, to give us 42 volts. Got to be really careful with your signs in these problems. Okay, so that takes care of our potential epsilon. What about our resistance R? I'll choose a different loop. This time I'm going to choose the whole outer loop. And again, I'm going to go around clockwise. Mostly when I pick my loops, I try and have my loops match my current direction. When I do that, it means that whenever the current direction matches the loop direction, there's a voltage drop across resistors and a voltage increase through batteries. So for loop 2, I've got my I3 and my loop going in the same direction through my 3 ohm resistor, so that's a potential drop of minus 6 amps times 3 ohms. Then I get to my resistance R, the loop and the current go in the same direction, that's a drop, The potential difference across that battery is I1, which is 2 amps, times the unknown resistor R. And then last I come to my battery. My loop is in the same direction as my current through the battery, so that's a potential increase of 28 volts. And that equals 0. So minus 6 times 3 is minus 18 volts. Minus 2 amps times the resistance R plus 28 volts equals 0. Minus 18 and 28 gives us plus 10 equals 2 amps times the resistance R. So our resistance R is 10 volts over 2 amps, or 5 ohms. Okay, that's that part done. Last, and this is kind of an interesting little addition, if the circuit is cut at point X, what's the current in resistor R? So that's going to change our circuit, and we're going to need to do a new analysis. So if we're cutting the circuit at X, we might imagine that there's a switch in this circuit. I'm going to redraw it, and I'm going to put a switch in. So we've got this battery. Now we've got a switch, and we're going to open up that switch, and we've got the 4 ohm resistor. So this is R, which was 5 ohms. This one is 3 ohms. This one is 28 volts. This one is 6 ohms. Now, in that part of the circuit, with the switch open, can't get a current flow. That's because there's no wire for it to flow through. So as soon as you open the switch or you cut the circuit, the branch with the open circuit cannot have a current flow. So if we wish, we can redraw that whole circuit and just leave that branch out altogether, because there's no current flow, so it does not impact the circuit. So now we've got a 3 ohm resistor and a 5 ohm resistor connected to a 28 volt battery. From here you got two choices. You could do an equivalent circuit and then calculate the current that way, or you could do Kirchhoff's loop rule. Since we're doing the loop rule section, why don't we go ahead with that one? So I'm going to pick a loop that looks like this. I'm going to pick a current that comes around like this. And when I write my loop rule, let's start with my battery. I have a potential increase of my battery, 28 volts. I have a drop through the 3 ohm resistor of current times 3 ohms. And I have a drop over the 5 ohm resistor, so minus current times 5 ohms. They all have to sum to give me 0. So 28 minus 3i minus 5i equals 0. Tells us that our current through that resistor would now be 3.5 amps.